What's going on, everyone? Welcome to the Panic Room, where we break down networking and real-world IT without the panic. Today we'll be covering router on a stick, one router, one switch, multiple VLANs. The plan is to use Cisco Packet Tracer to demonstrate how to get multiple PCs and multiple networks communicating with each other. At the moment, we have 6 PCs. The 2 on the far left, those are slated for VLAN 10. User PCs, the 2 in the middle, slated for VLAN 20. Those will be our servers. Then on the far right, 2 slated for VLAN 30, which are our sales team. All 6 PCs are connected to the 2960 Cisco switch. That switch currently has no config, and every interface is in its native VLAN of 1. Above our 2960, we have our ISR 4331 router. It has no config, and the interface that is connected to the switch is currently shut. Let's dive right in. I'll show you that. Do a show run. I have it connected to gig 000. As you can see, it is shut down. Now keep in mind, router on a stick uses one physical interface connected to the switch. That link is configured as a trunk and carries multiple VLANs across the cable. On the router, we create sub-interfaces. So instead of using 3 physical router ports, we take one interface and split it up logically. And we can dive right into that right now. But wait, before we do that, let me prove to you that these PCs on separate networks can communicate with each other, but not with the other PCs in the different network. So we will open up this PC right here. This is PC2 in sales, as you can see down here. It has 192.168.30.6. Open command prompt. Let's ping sales 1. Do the -T 192.168.30.5. Ping responses right away. Now let me ping something. We will ping server 2 20.6. Hang out for a few seconds. I don't want this to go too long. As you can see, it's just timing out. That's because we do not have any type of routing configured on the router yet. Let's jump on this router, config some sub interfaces, do a no shut on the trunk link, and then we'll hop over to the switch, config those interfaces, put every interface in its designated VLAN, and get those PCs talking to each other down below. So first thing we'll do, this is a fresh router. Hit a no on the initial config. Get to enable mode. First thing we'll do is just show IP interface brief, just because it's how to get your bearings when you jump on a router or a switch. So we are going to use Gigabit Ethernet 000. So let's jump into config T mode, interface. We're not actually going to do anything on the actual gig 000. We're going to create a sub interface off of that. And to do that, we will just do interface GI 000.10. Now we're into the config of the sub interface. This is where we'll turn it into a VLAN. We're going to encapsulate .1Q 10. The 10 matches up to VLAN 10. That's why if you look over on user 1, user 2, that third octet, I'm lining that up with the VLAN. Now we have to give this interface an IP address. Now this IP address is actually the default gateway for any PC in VLAN 10. We'll give it a subnet mask. These are all /24 networks for CIDR notation. All right, that one was all set. Let's do couple more. VLAN 20 on its way. Encapsulate .1Q20. Give it the IP address. All right, let's bang out the last one. VLAN 30 coming up. Let's jump on the interface and do a no shut, because it wouldn't work if we didn't do that. Interface GI. Now we're just gonna go straight. Pick 000, no shut. We'll see the router and the switch will turn green. Do WR, save that config. Jump right on the switch. Let me move it out of the way here. As we can see, as we were making changes on the router, our interface has started to come up. I think this is a brand new switch. Yeah, interface. We're going to use 1 through 6 for our 6 PCs. Nothing configured quite yet. Gig Ethernet 01, nothing config. Let's put that into trunking mode. 01. That is, we have to switch ports, trunk, encapsulate. Maybe not. Let's see. Okay, back to throwing this switch into trunk mode. Switch port mode trunk. All right, you'll see those interfaces change state to up. This link over here will be green and green in just one moment. Your PC still uses its IP address to determine where traffic needs to go. It checks its own subnet mask and says, is this destination on my local network or do I need a router? If the destination IP is on the same subnet, the PC knows it can stay local. And what I mean by local is these two PCs can talk. They can see each other because they're in the same network. So the traffic will go from sales 2 up to the switch and right there shoot back down to sales 1. That's considered staying local. When you're traversing networks, if we take sales 2 and try to communicate with user 1 over here, what's actually happening is our frames are going up to the switch and then it realizes it needs to get off that network. So it's going to go up to the router. That's why we configured all those default gateways. That's where the routing happens. It's going to know how to turn that traffic from 192.168.30.6 and route it over to 192.168.10.5. And it'll just come down that same physical interface and out that interface that's in VLAN 10. Last will be VLAN 30 in range 0/5 and 6. Switch port access VLAN 30. It's going to create it. Switch port mode access. Let's do a show run. All right. Our first 2 fast Ethernets, VLAN 10, 20, and 30. They are all open, they are not shut. So let's jump on a PC. If the first ping doesn't happen, it's because ARP is doing its thing. Just something you learn to deal with in the field. So looks like we're gonna ping server 2. Okay. I was hoping to catch ARP doing its thing, but it looks like, all right, here we go. We'll give it a minute. See that first ping? It's the thing out there. Learn to live with it. Learn to get used to it. Don't get scared. You'll be all right. Now, while we're in the lab, let's just have a little fun. So what we'll do is we're going to, on sales 2, which is 192.168.30.6, we'll ping user 1. That had a -T in there, so it's going to continuous. Let's just go on the router. See if we can bring up both here. There we go. Let's shut the sub interface on the router. So config T. Let's just jump into interface GI 0/0/0.30. Now, when I do this, the ping should stop. Everything goes to down. I think our ping just stopped. Hopefully we get a couple requests timed out. Good. Get one more. All right, let's do a no shut on that sub interface. Try to move this over so we can see it come back up. Give it a couple more seconds. There we go. And we're back. Always like to experiment with little things like that, just so if you're ever working in the real world, you'll kind of know what to expect. That's why Packet Trace is so good. You can really lab up real world scenarios. So I want to try to explain something that I think might confuse a lot of people, especially if you're just starting out in networking. So what we did was first demonstrate how PCs can communicate at layer 2, and they couldn't until we added routing, which is layer 3. The whole concept of router on a stick, I think, was really in play early 2000s, around that time frame. I don't see it much anymore, but then again, I really don't configure small offices anymore. This type of setup is great for a small office. Once we break into enterprise level networks, this concept, having a layer 2 only switch that has to get its routing from an actual router, creates a bottleneck. So we will transition in later videos to a more multi-layer switch that can handle routing, can handle IPs. We'll get into terminology like SVIs, and those multi-layer switches really help bigger networks scale a lot easier. We can add redundancy. We'll go over all of that. We'll lab all that up. But for beginning, it's kind of a rite of passage to learn router on a stick. You can go on eBay. You could probably, if you know anybody in IT, you could probably even get some hardware on your hands, connect everything, fill those physical cables, or just do it in Packet Tracer or GNS3. Once we get into more enterprise level stuff, we're going to switch over to GNS3. I plan on doing a build, how to configure GNS3. I'll show you my lab. We have both Arista and Cisco images we can use. So it's a lot of fun over there. But for now, thanks for watching.